All right, so economists are all about causal inference, this idea of getting to the bottom of what is the causal effect of X on Y. And oftentimes this is going to be like some specific policy, or it could be, a price change, or it could be any number of things. But what we're really trying to get at is not just, when that thing changes, does some outcome also change? At the same time, we're trying to get at what is the causal effect of this change on this outcome, right? So in this video, we're going to get into that through this framework the economists call the potential outcomes framework. It's also called the Rubin model, right? And we're going to use this specific example to try to help us kind of think through these ideas. We're going to think about a hearts and minds counterinsurgency campaign, right? So the question that we might be after here is, does an infrastructure program, maybe it's a school building program or something like this, if we were to implement that program in a given city, would it reduce violence in that city? Okay, so this is sort of the conceptual example that we're going to use to kind of get into these ideas of causality. So if you were confronted with this question by someone, you might go to an example where there were some infrastructure programs put in different cities. I'm going to use cities in Iraq for this example. And you might go around and you say, okay, which cities were treated, right, in quotation marks. Economists like to borrow some of the terminology from these pharmaceutical trials, right, where one group is treated and the other group gets a placebo or is not treated. We're gonna borrow that language, right? But here, treated just means that they got the program, or more broadly speaking, like that they were affected by whatever change you're interested in. Okay, so one way you might try to get at this is to look at the average violence in cities that were treated, cities that got this infrastructure program. We're going to call this treatment variable D. So DI equals 1 is, did some city I get the treatment, right? Then DI equals 1. If city I did not get the treatment, then DI equals 0. Okay. So we take the average for the treated cities, we take the average for the non-treated cities, and we compare the violence across those two groups. Okay, so let's think about that. What could be a problem with that approach if we're trying to draw out the causal effect of this infrastructure program on violence, right? Is this going to tell us that if we put an infrastructure program in any given city, we're going to see a reduction in violence? Well, the issue here, and this is going to bring us to this idea of potential outcomes. The issue here is what would have happened in these treated cities had they not received the treatment, right? And sort of more in layman's terms, right? What the big question here is, are we getting an apples to apples comparison, right? Do these treated cities look like these non-treated cities, except that they got this infrastructure program, right? If they don't, if they're kind of different types of cities, then we can't really infer causality from just looking at the differences between these two groups on average, right? And that's what we're going to try to use this potential outcome framework to kind of think through a bit. Okay, so what do I mean when I say potential outcomes? Right, so we have this basic idea of potential outcomes. I think the way I like to kind of conceptualize it is think of there being two doors, right? So for a given city in this case, or sometimes we talk about individuals as the people being treated, but for a given city, there's sort of two doors. One is what would happen to that city if it got the treatment. One is what would happen to that city if it didn't get the treatment. Right, and so we call those the two potential outcomes for that city. So the outcome Y of city I, and then the subscript 1 is our way of sort of writing this idea that this is what would happen to city I if it received the treatment, right? yi0 is how we write, you know, the outcome that would happen to city I if they didn't receive the treatment, right? If they didn't get the treatment, okay? So, you know, the notation can get a little tricky. So you want to make sure as we go, we're going to be sort of adding additional pieces of notation, right? And it's important to not sort of freak out when you see a bunch of math, right? It's just another language, right? It's another way of writing concepts. We use math because it's a much it's a shorter and easier way to sort of concisely convey a lot of information, right? But you got to sort of get up to speed in the language a little bit. Okay, so don't freak out if there's math. We're going to be using math. Just take it kind of step by step, right? You know, just the way you would if you're reading a new language, right? You know this word, you know this word. Now you put them together. What does that mean? Et cetera, right? Sort of build it up. Okay, little aside there. So we've got these two potential outcomes. What's behind one door? That's what would happen to the city if it receives the treatment. Behind the other door, that's what would happen to the city if it didn't receive the treatment. The trick here, and this is sort of the fundamental hurdle with all of this causal inference stuff, is that you can only see behind one door, you know, for a given city at a given point in time, right? So we can never see what would happen to city I. Let's just pick a city. So we never see what would happen to Mosul if it gets the treatment, if it gets this infrastructure program, and if it doesn't get the infrastructure program, right? Because that's what we would really want to know, right? We want to know what happens if it gets it, what happens if it doesn't get it at the same point in time for the same city. That would tell us the causal effect of this program, right? That's sort of what that's what we're after, right? So we're going to talk a lot about this idea of the counterfactual, right? And simply put, this is what's behind the door that you don't actually get to see, right? Another way of saying it is what would have happened in some treated city if it had not been treated. That would be the counterfactual for a treated city. So let's say Mosul gets the infrastructure program, right? We see, you know, what the outcome is then. We're actually going to see that, right? Because that's what happened. That's a door that we got to open. The counterfactual is what's behind that other door that we never got to open, right? What would have happened if Mosul didn't get that infrastructure program, right? So it takes a little, you know, you got to think about it a little, let it sit with those ideas a little bit to let them sink in, right? But basically you want to think about these two doors, like what's behind these doors as set in stone, right? There is a potential outcome here. There is a potential outcome here. It's just only one of them is going to be revealed by what actually happens, right? So which door gets opened is sort of which of these potential outcomes that we're actually going to see. All right, so let's take a couple examples here. So let's say we've got just two cities. We'll start out sort of small, and then we're going to build it up a little bit. So let's say we got two cities for our hearts and minds scenario. We've got Ramadi and Mosul. Right? And we're going to pretend here that we can see behind both of those doors. Obviously, that's not what we would actually see in real life, right? If Mosul was not treated and Ramadi was treated, we would see this potential outcome. We'd see yi1 for Ramadi, right? Because it actually gets treated. So we're going to see what happened if it got treated. And we're going to see the potential outcome without the treatment for Mosul because it didn't actually get the treatment, right? So it went without the treatment. So we're going to see that what's behind that door. We're not actually going to see what's behind the other doors, right? For Ramadi, we're not going to see the potential outcome without the treatment, okay? And vice versa for Mosul, right? So So I bolded here what we actually get to see, but since this is a simple little example, we're going to pretend we can also see behind the other door just to sort of help us get some intuition here. So let's think about what the observed difference between the violence in these two cities would be. Right? And let's just remember that Ramadi is treated and Mosul is not treated. Okay. So let's think about the difference in our observed outcomes, right? So we see YI1 for Ramadi. I'm going to call that YR1. I'm going to use letters for now. Later on, we'll make these numbers, but it's a little easier to think about with letters for starters. Right, so we see that, and we see YM0, right? So this difference is a bit like what we were talking about before, sort of you're just comparing the outcome for the city that gets treated to the outcome from the city that doesn't get treated. That's the difference that we observe. In this case, we'll think about the outcome as violence, right? We'll think about Y as being violence. Okay, so we've got that. Now I'm going to do something that's going to seem a little odd, but it's going to give us a little bit of intuition about how to think about these things, okay? And what I'm going to do is I'm going to add and subtract this term over here, YR0 minus YR0, right? So I've added and subtracted the same thing, so this is still an equality, right? I just added an extra term. So that's fine, right? And now let's think about what we've done here, right? So we've added this counterfactual for Ramadi, and we've subtracted this counterfactual for Ramadi. Right? That's the potential outcome that we don't actually get to see for Ramadi. Now I'm going to rearrange things a little bit. Right? I'm going to put this YR1 with this with this minus YR0, and I'm going to put this YR0 with this minus M0. All right. So let's think about what we've got here. So what is this first piece telling us? This first piece here. We've got the potential outcome for Ramadi if it gets the treatment, minus the potential outcome for Ramadi if it doesn't get the treatment. Let's see if I can draw here. All right. So what do we got here? Well, potential outcome if you get the treatment minus potential outcome if you don't get the treatment, that's the effect of the treatment, right? That's getting at our treatment effect. So that's the treatment effect of this infrastructure program, right? Now the other question is, what is this piece over here, right? So here we have the potential outcome for violence for Ramadi, if they don't get the treatment, minus the potential outcome for violence for Mosul, if they don't get the treatment. So in other words, that difference there is what would the difference between Ramadi and Mosul be if neither of them got the treatment, right? So that's the piece that's getting at this idea of whether we have an apples to apples comparison, right? Would Ramadi and Mosul look the same if not for this infrastructure program, right? And we're going to call this, there's a few different terms we could use here, but we're going to call this the selection bias, right? And what I mean by that, and we're going to talk some more about this, what I mean by that is this is how different well, in this case we just have one, is the city that's treated versus the city that didn't get treated. How different are those two cities if neither of them got got the treatment, right? That's our selection bias, right? Is the cities that are selected for the treatment, do they look different from the other cities, right? So in other words, just to sum this piece up, right? When we look at the average observed difference, or in this case, we just, there's only one outcome, so we're just looking at the observed difference. We've got the observed difference between the treatment group and the control group. Part of that is going to be the treatment effect. And part of that difference is going to be the selection bias, right? The extent to which these aren't apples to apples comparisons, right? So in this case, in our sort of simple example where we've like let ourselves peek behind the door we don't actually get to see, we can look at what this actually would end up being. So in our case here, we have 250 minus 150 is our observed difference, right? That's what we actually see in Ramadi and what we actually see in Mosul. And here we've got 250 minus, so I'm going off the first line here, 250 minus 300 is, sorry, no, I'm going off this line here. So 250 minus 300 is the difference between Ramadi, the potential outcome of Ramadi with the treatment versus without the treatment, plus 300 minus 150, right? So what are we learning here? Well, we've got an observed difference of 100 between Ramadi and Mosul, that we observe. And that's made up of a drop in violence of 50 for Ramadi. So that's our treatment. That's our treatment effect. We're saying that, if we could see behind both doors, we'd see that this infrastructure program reduced violence in Ramadi by 50. I haven't given units because we're just sort of doing a kind of hypothetical example. If you want units, you can think about, 50 violent incidents in a year or something like that, right? So we have a minus 50 treatment effect here, plus this selection bias, which is saying that if not for this program at all, if this program never showed up, right, Ramadi would be much more violent than Mosul, right? There'd be 150 more violent incidents in Ramadi than Mosul. So when we see this observed difference of 100, right, we shouldn't jump to the conclusion that, this infrastructure program increased violence, right? I mean, that could be the case. We don't know because we can't see behind all the doors. But in our example here, we see that observed difference is masking this actual good treatment effect of reducing violence, of this program reducing violence, because these cities look a lot different to begin with, right? It's not an apples to apples comparison, right? So that's our selection bias there. So that was the two-city example. Obviously, we're never really going to be, we got all this big data. We're not going to be interested in just like these two cities because there could be all sorts of other things that are going on if you only have a couple observations, right? We're going to be after situations where you got lots of cities and you're looking at kind of averages of these things. So let's talk about that. Oop. Let's talk about that. There we go. All right. So let's do another example where we've added a bunch more cities here. So yi is going to be our observed measure of violence, right? If we throw a 1 or a 0 next to that I, that's telling us that we're talking about a potential outcome of violence, right? Di is our treatment status, right? That's, in other words, that's did the city get this infrastructure program or did it not get this infrastructure program, right? Then we have a bunch of different cities, and I is our, we've numbered the different cities, right? So we have I 1 through 5. Okay, so what we're after in these sort of many city example, it's a little bit more complicated, but not that much, right? What we're after, instead of just taking the difference between, the potential outcome of Ramadi if it gets the treatment and the potential outcome if it doesn't get the treatment, what we're after here is the average of those differences across all of the cities, right? So what would happen if the city gets the treatment versus what would happen if it didn't get the treatment? We're taking the average of those across all the cities, which is the same as saying what would be the average violence for all the cities if they got the treatment minus the average violence for all the cities if they didn't get the treatment, right? And if you're interested in sort of why that is, it has to do with, our rules for expected values. I'm going to assume that you guys have kind of an understanding of what an expected value is and what a conditional expected value is. If you don't, this would be a good time to, pause and go back and look at your notes from econometrics to make sure you're up on that. So basically, expected value, that's the average is sort of how we're going to be thinking about it. In this case, the average across our data. And the conditional expected value is going to be, the average within some subgroup of the data, conditioned on some variable in the data. And you'll see what we're doing there. I assume you guys have seen this before, so I'm not going to spend much time on it. Okay, so this is just, we're using the rules of expected value to prove this. You guys can take a look at that later. It's not really central here. The important thing that we're going to be assuming as we go through here, for starters, right? Obviously, like as you get to more complex econometrics, we can loosen this assumption a lot. But basically, for our purposes today, we're going to be assuming that there's some constant treatment effect across any city, right? So we're going to assume that the effect of the program in Ramadi would look a lot like the effect of the program in Kirkuk, right? In other words, Ti is going to be equal to some constant t. Sorry, tau I is going to be equal to some constant tau. Okay, so that means for any given city I, the potential outcome, if they get the treatment, is going to be equal to the potential outcome if they don't get the treatment plus this tau, right? It's constant across different cities. So given that, let's take a look at what our previous sort of example would look like when we've got lots of cities and we're looking for the average. We're looking at average differences instead of just a simple difference. Okay, so here we have the average difference. Let's see if we can get this all on the screen at once. There we go. Okay, so what we want is the average difference between the treated cities and the not treated cities, but we want to put it in our kind of potential outcomes language, right? So what's that going to look like? All right, let's dig into this for a second. What do we got here? So we got the expected value of yi1. So the expected value of city I, if it gets the treatment, given that city I gets the treatment, right? So in other words, we're taking the average for all the cities that got the treatment, we're taking the average of the potential outcome if they get the treatment. Okay, I'll let that sit for a second. It's a little hard. So in other words, this is the average that we actually get to see. This is the average of, so we sort of look at all the treated cities. Here we got Ramadi, Tikrit, and Karbala, I think. And we're taking the average of this measure of violence, right? Because this is for these guys, this is also the potential outcome if they get treated, right? Going back to here, right? So we've got the potential outcome with the treatment, right? We've got these two doors, right? This is we're looking at the average of what's behind this door, this potential outcome with the treatment. We're looking at the average of that for all the cities where we actually opened that door. So we actually got to see it. Okay. Second piece, the same idea. We're taking the average, like for the group that doesn't get treated, we're taking the average of the potential outcome without the treatment, right? So we're looking behind the other door. So we're saying, what's the average of what's behind this other door for all the cities where we actually got to open that other door? All right. So let's take a look. Well, let's do the same thing that we did last time, right? So we're gonna add and subtract this kind of counterfactual term here. So we've added and subtracted this piece. So we're looking at, for the cities that get the treatment, we've added and subtracted the potential outcome had they not gotten the treatment, the potential outcome without the treatment. So this is something we don't actually observe in practice, right? This is what's behind the other door that never got opened for this group, okay? And likewise here. So this is fussy. Why is this being so fussy? All right. Okay. So we've got this guy here, and just like before, right? We can see that. So we can break this down, right? So here we have the average of the observed differences. This guy here is going to be our average treatment effect right, we've been calling this tau. And then this guy here is our selection bias, right? Because what is this telling us over here? This is telling us so this is like the average of what these cities that got the treatment, what would they have looked like on average if they didn't get the treatment? And this is the average of these cities that didn't get the cities that didn't get the treatment, what they look like when they didn't get the treatment. So we actually observe this piece, right? But we don't observe this piece. So in other words, what we've got here is how different would these two groups look if neither of them ever got the treatment, right? If there was never an infrastructure program. That's our selection bias, right? It's going to be positive if the more violent cities are the ones that end up getting the treatment, right? It's going to be negative if the less violent cities are the ones that end up getting the treatment. Okay, so just like before, just with averages here, we've got the average observed difference is going to be, it's going to include that treatment effect, that average treatment effect, but it's also going to include this selection bias. So we want to be careful when we're interpreting something that's this average difference, that it may not just be the average treatment effect. That we could have some problem with not having an apples to apples comparison here as well. Okay, so this is sort of what applied economists are doing all the time, right? We're trying to hunt down this bias. We're trying to figure out situations where we've got nice apples to apples comparisons so that we can compare two groups of apples, right? And get at this treatment effect, right? Situations where this term here, this selection bias term, right? The average of what these two groups would have looked like if not for the treatment, that looks like 0, right? Because when that looks like 0, when we kill that, all we need to do is make this comparison, and we've gotten that real treatment effect that we're after, right? So it's actually a very difficult thing to do, as we'll see, to really get at that treatment effect. But that's what we're doing when we implement all these different kind of empirical strategies. When we look at something like a difference in difference or a randomized controlled trial, that's the sort of thing that we're after, right? We're trying to kill this selection bias term so that we can look at a difference and say, oh, that difference is this average treatment effect, right? That average difference is that average treatment effect.